Hello. I'm glad you're here with me as we explore a fascinating correction in our stellar maps, because our observable universe is actually smaller than we once believed. That distant frontier we accepted as certain has revealed itself to be much closer than we imagined. Did you know that recent revisions indicate the portion of the cosmos we can truly interact with is drastically more restricted than classical estimates once suggested? Accelerated expansion doesn't just define a boundary. It is actively shortening the effective reach of our future light. If our cosmic backyard has shrunk in the equations, what does that change in our sense of vastness? Let's understand how recent studies recalculated this visible radius and the physics behind this reduction. Let's imagine what it would be like to see the edges of the map slowly closing in around us. Let's walk through the evidence that our event horizon is closer than we thought. Let's feel how this discovery transforms the universe into a more intimate place. But before we continue, I'd like to invite you to support this work. If you find value in these reflections, consider subscribing so you won't miss future explorations, and feel free to share this journey with someone who might appreciate a quieter, scientific view of the cosmos. Your support helps Cosmos for Rest continue creating thoughtful, calming science for curious minds. Now, relax, close your eyes, and let science gently guide you. To truly understand the dimension of the place we inhabit, we must first draw in our minds the fundamental architecture of the night. When you look at the starry sky, far from city lights, the immediate sensation is that of a bottomless abyss, a depth stretching forever in every direction. This is humanity's oldest intuition, the idea that the stage of the stars is eternal and infinite, an ocean without edges where we could sail endlessly without ever encountering a wall or an end. And yet, modern science has offered us something far more fascinating and complex. The realization that we live inside a very specific sphere, a bubble of illuminated reality we call the observable universe. For a long time, we imagined that this sphere was merely a temporary limitation of our vision, a fog that would dissipate as our telescopes became more powerful. We believed that with larger lenses and more sensitive detectors, we could see farther and farther, forever pushing back the boundary of the unknown. But physics has taught us that there is a rigid barrier, not because of technological limits, but because of a fundamental law of nature. Light has a finite speed. It travels at 300,000 kilometers per second, a velocity that feels instantaneous on the human scale, where we flip a switch and a room brightens immediately. Yet on the scale of the cosmos, it is a slow and patient step. Because the universe has a defined age, born about 13.8 billion years ago, light has had only that specific amount of time to travel toward us. This means there is an absolute geometric limit in space. We can only see objects whose light has had enough time to cross the distance between them and Earth since the beginning of time. Everything beyond that distance remains in darkness, not because it does not exist, but because its luminous message is still on its way, or may never arrive at all. This boundary forms a perfect sphere around us, the particle horizon, which defines the edge of our map. For decades, astronomers and cosmologists worked with grand estimates of the size of that sphere. The equations, based on the cosmic microwave background radiation and the rate of expansion of space, suggested a colossal diameter. We became accustomed to reciting astonishing numbers, speaking of a radius of 46 billion light-years. It was a figure that conveyed almost incomprehensible vastness, a territory so immense the human mind could barely process it. It seemed to leave room for infinite possibilities, infinite civilizations, infinite stories. That estimate became the standard, the number printed in textbooks, featured in documentaries, repeated in academic lectures. We accepted that vastness as a guarantee, a promise that our cosmic backyard was as large as it could possibly be within the rules of physics. Yet science is a living narrative, constantly correcting and refining itself. More recent studies, carried out by physicists such as Paul Halpern and Nick Tomasello, began to revisit these calculations with stricter mathematical precision, using updated data from the Planck mission, which mapped the echo of the Big Bang with unprecedented clarity. When they cross-referenced the data on the universe's expansion rate and the density of matter, they found a subtle yet profound discrepancy. The numbers did not align perfectly with the grandeur we had assumed. By refining the margins of error and applying stricter models for how light travels through stretching space, the conclusion was surprising. The radius of our observable universe is, in fact, smaller than previously thought. This reduction is not merely a comma adjustment or an irrelevant technical detail. It represents a shrinking of our known frontier. The sphere that surrounds us is slightly tighter. The horizon is slightly closer. That margin of safety we believed existed at the edges of the map. Those distant galaxies we assumed were comfortably within our theoretical field of view may already, in reality, be forever beyond our visual reach. It is like discovering that the walls of your house are a few feet closer to the center of the room than the original blueprint indicated. This discovery compels us to rethink our relationship with space. The observable universe is not a static concept. It is a dynamic stage where light and darkness wage a silent battle. Light attempts to reach us, carrying information from the past, telling the story of stars that were born and died long before Earth existed. But space itself, driven by a mysterious energy, is expanding, creating more distance every second, attempting to pull the source of that light away from us. When scientists state that the observable universe is smaller than previous estimates suggested, they are telling us that expansion may have been underestimated during certain epochs, or that the geometry of the early universe was slightly different than assumed. The edge of the precipice, where ancient light finally ceases and mystery begins, is not as far away as we once dreamed. There is a new intimacy in this realization. The cosmos, suddenly, feels less like an indifferent infinity and more like an enclosed chamber, a celestial dome with precise and finite dimensions. Imagine yourself floating at the center of this sphere. Before, you saw the edge as extremely distant, almost unreachable, lost in a haze of uncertainty. Now, with the new calculations, that edge gains definition and draws nearer. You realize that the number of galaxies, stars, and matter with which we can exchange glances is limited. It is not infinite. It is finite, countable, precious. Every galaxy we observe within this reduced radius becomes more valuable because it belongs to an exclusive set that managed to send its light to us before the door began to close. This correction in our stellar maps is the starting point of our journey tonight. We are no longer navigating an endless sea, but exploring a very well-defined island. Understanding that the observable universe is smaller than we thought should not cause claustrophobia, but rather a sense of location. We know where we are, we know how far we can see, and most importantly, we begin to understand that what lies within this sphere is all we truly have. The illusion of infinity dissolves to reveal the beauty of finitude. As we look toward this new frontier, closer and clearer, we are invited to let go of the anxiety of trying to embrace the unreachable whole. Instead, we can turn inward, toward the immense richness that still fits within these newly drawn boundaries. The universe has shrunk, but our appreciation for what remains should expand. The light reaching your eyes right now, coming from a distant star, won an unimaginable race against time and expansion simply to be here. It crossed an abyss that we now know is more dangerous and more exclusive than we once imagined. The opening scene of our story, then, is this: humanity awakening to the reality that the sky has a size, that the window through which we look at creation has a frame, and that this frame is slightly narrower than the architects of the past had drawn. We are safe within it, protected by the laws of physics that prevent us from being crushed by total vastness, yet also isolated on our island of light. It is here, inside this recalculated and corrected sphere, that our lives unfold, surrounded by the silence of what lies beyond, of what the universe, in its relentless expansion, has chosen to hide from us forever. Bring that theoretical immensity down to the scale of your breathing, into the quiet space where you are at this very moment. When we think about the observable universe being smaller than we once imagined, the first reaction may be intellectual surprise. But in the lived experience of our senses, this discovery translates into something deeply comforting. Imagine you are in your bedroom, lying down, feeling the gentle weight of the blankets. The walls around you define your immediate observable universe. They are not a prison. They are the boundary that allows the space to be warm, safe, and understandable. If those walls were miles away, you would feel exposed, lost in a hall too vast and cold to inhabit. The fact that the universe has brought its cosmic walls slightly closer, according to these new calculations, works in a similar way. It transforms the cosmos from an infinite and impersonal hall into a kind of celestial chamber, vast enough to inspire awe, yet finite enough to embrace us. This reality reveals itself in the way light touches your eyes each night. Light is the only messenger we have. It is the letter the universe sends to say, I exist. And yet even this messenger has limits. In daily life, light feels instantaneous. You switch on a lamp and the corner of the room brightens without delay. But when we look at the sky, we are dealing with scales where light grows weary, where the journey is so long that the geometry of space itself begins to distort the message. Living in a smaller observable universe means that the light reaching us is a survivor. Every photon striking your retina when you look at a star is a traveler that managed to overcome the expansion of space before the door narrowed. Consider the simple act of looking at the moon. The light you see reflected from its silver surface took about 1.5 seconds to arrive. It is a tiny delay, almost imperceptible, yet it teaches us a fundamental lesson about our cosmic routine. We never see the absolute present. We live in an eternal now constructed from fragments of the past. When we look at the sun, we see it as it was 8 minutes ago. When we look at the nearest star, we see it as it was 4 years ago. As we look farther, we enter increasingly distant pasts. The observable universe is, in truth, a historical archive, a library of visual memories. Knowing that this archive is smaller than once believed means that our accessible collection of memories is more exclusive. We do not have access to everything that ever happened. We have access to a carefully limited curation of events that nature allowed us to witness. This awareness transforms the quality of the night's silence. When you step onto a balcony or look through a window at the dark sky, the darkness between the stars is not merely emptiness. It is the boundary. It is the edge of our bubble. Before, we could imagine that darkness as territory waiting to be conquered by better telescopes. Now we understand that part of that darkness is final. It is the veil that protects our sanity from total vastness. In our human experience, we have a biological need for limits. We like fences, walls, horizons our eyes can reach. The ocean horizon calms us because it is a defined line. The mountain horizon comforts us because it draws an end to the landscape. The universe, in revealing itself as finite in its observability, offers the greatest comfort of all, a final horizon. This also reshapes our sense of belonging. If the universe were infinitely accessible, with infinite visible galaxies, we would be a grain of dust lost in an endless sandstorm. Our light would dissolve into trillions of others. But within a reduced observable universe, our galaxy, the Milky Way, and our small solar system gain prominence. We are part of a select collection of objects sharing this connected space-time. It is like living in a small illuminated village in the middle of a vast forest, rather than being lost in an infinite metropolis. The village is smaller than we thought, the neighbors fewer, and that makes each neighbor, each visible star, more meaningful. Observing the sky becomes an act of communion with what is truly within reach. We no longer need to feel anxious about missing something unimaginable in unreachable depths. What matters is what lies here, within the horizon. The beauty of the Orion Nebula, the blue brilliance of Sirius, the faint smudge of Andromeda, all of it is inside our home. All of it lies within the radius physics has permitted to exist for us. The shrinking of the cosmic map validates our local experience. It tells us we do not need to travel to the edge of infinity to find meaning. Meaning resides inside this sphere of light surrounding us now. Imagine starlight as a gentle rain falling upon us. In an infinite and static universe, that rain would be torrential and blinding. The night sky would blaze white with countless stars, as suggested by Olber's paradox. But we live in a universe that expands, that has a finite age and, as we now understand, a more restricted visual reach. That makes the rain of light soft, spaced, delicate. Each drop of light is precious. Darkness is necessary so that brightness can be appreciated. To experience this theme is to experience contrast. Our vision is limited so that it may be focused. When you fall asleep, you close your eyes and create your own personal event horizon. The external world fades, sounds soften, and you retreat inward. The universe does something similar with us on a grand scale. It draws the curtain at a certain point. It says, "You may see this far. Beyond that lies mystery." And there is profound peace in accepting mystery. We do not need to know what exists in galaxies that expansion has carried beyond our sight. We do not need to worry about worlds we will never encounter. Our responsibility, and our joy, is to care for and admire this enclosed garden that is the observable universe. Life within this recalculated bubble is more intimate. Gravity keeps our feet on the ground, the atmosphere allows us to breathe, and the particle horizon defines the ceiling of our cathedral. Knowing that this ceiling is lower than previously estimated does not diminish the majesty of the structure. It improves the acoustics. It makes our presence and our voice more relevant. We are the observers of this specific slice of reality. If the universe were infinitely accessible in every direction, our observation would dissolve into irrelevance. But because it is finite, and now understood to be smaller, our act of looking up gains weight. We are the witnesses of this particular volume of space. Feel now the tranquility of being contained. Just as your blanket surrounds you and defines the boundary of your warmth, the horizon of the universe surrounds Earth and defines the boundary of our causal reality. Nothing happening beyond that horizon can reach us. No cosmic catastrophe, no distant explosion occurring past that edge will ever affect us. We are shielded by distance and by expansion itself. It is a natural safety zone. The observable universe is our cradle, and discovering that it is smaller is like realizing the cradle is perfectly sized, so we do not feel lost within it. It is a measure of protection, not deprivation. Each night as you lie down, remember that you are at the exact center of your own observable universe. For every person, the horizon is slightly different, centered on their own eyes. Yet we all share this same comforting limitation. Science, by adjusting the numbers and bringing the borders closer, has given us a philosophical gift, permission to stop worrying about unreachable infinity and to begin loving accessible finitude. It is an invitation to cherish the cosmic here and now, the light that arrived, the star we can see, the air we breathe. The rest is silence, and silence is the finest companion for sleep. To truly understand how our stellar map was rewritten and why the borders of our world are narrower than we once assumed, we must descend into the silent machinery that moves the cosmos. It is not enough to look at the sky. We must understand the mechanics of light and time, the two fundamental fabrics that stitch reality together. What defines the size of the observable universe is not simply the physical distance between us and the stars, but a complex relationship between the speed at which light travels and the speed at which space itself is being created between us and the source of that light. It is a delicate and invisible dance, where the ground is moving even as we walk upon it. At the heart of this mystery lies a concept physicists call light cones. Imagine that every event in the universe, the birth of a star, the collision of two galaxies, is like a stone thrown into a still lake, ripples spread outward in perfect circles, traveling through space and time. These ripples are light, gravity, causality. For us to know that something has happened, the ripple from that event must reach us. If it does not arrive, then for all practical and physical purposes, that event does not yet exist for us. The observable universe is therefore the collection of all ripples that have had sufficient time, since the beginning of everything, to reach Earth. The mechanism that has made our universe smaller in these new calculations lies in the precision with which we measure the expansion rate of space. For a long time, we used a slightly imperfect cosmic ruler. We assumed expansion followed a certain rhythm, based on the visible matter we could detect and the gravity we could calculate. But the discovery of dark energy introduced a powerful new variable. This mysterious energy acts like a pressure opposite to gravity, pushing the universe outward and accelerating expansion. What recent studies have done is refine the impact of this acceleration on the path of light itself. Think of light from a distant galaxy trying to reach us as a swimmer attempting to cross a river against the current. If the current is gentle, the swimmer advances steadily. If the current is strong, progress slows relative to the riverbank. But if the current accelerates over time, there comes a point when, no matter how fast the swimmer moves, the river begins carrying them backward. The current is the expansion of space. The reassessment of the observable universe's size comes from recognizing that this current is stronger and more decisive than earlier models predicted at certain scales. This means that light from objects we once believed would eventually arrive, or that seemed safely at the boundary, has in fact already lost the race. The swimmer will never reach the shore. The effective horizon, the region from which light can still reach us, has moved closer. Another profound component of this mechanism is what we call the surface of last scattering. When we look as far as possible into the universe, we do not see emptiness. We see a primordial wall of fire that cooled with time, the cosmic microwave background radiation. About 380,000 years after the Big Bang, the universe was a dense, hot plasma so thick that light could not travel freely. It was like a luminous, impenetrable fog. Only when the cosmos expanded and cooled enough for atoms to form did that fog clear, allowing light to move unimpeded for the first time. That wall marks the absolute limit of our optical vision. We cannot see beyond it because before that moment, the universe was opaque. The new calculations refine the precise distance to that wall. Using high-precision satellite data such as that from the Planck mission, scientists measured tiny temperature fluctuations in this ancient radiation with extraordinary detail. These measurements function like a DNA test of the infant universe. They reveal the exact density of matter, the rate of expansion, and the curvature of space at that primordial moment. When those parameters are adjusted with maximum precision, the derived age and size from the equations shift accordingly. It is like adjusting the focus of a camera lens. The image sharpens, and we realize the object sits slightly closer than we previously thought. Clarity revealed that the radius of our visible domain is more contained. There is also a subtle mechanism often overlooked: the difference between where a galaxy was when it emitted its light and where it is now. When we observe a galaxy billions of light years away, we are seeing a ghost. The light traveled for billions of years to reach us, but in that time, expansion has carried the galaxy itself much farther away. The co-moving distance, the actual present-day separation, is far greater than the distance the light physically traveled. What recent studies emphasize is that the region of space containing objects still causally connected to us, objects with which we could theoretically exchange signals, is surprisingly small. The distinction between the particle horizon, what we can see from the past, and the event horizon, the boundary of what we will ever see in the future, becomes crucial. The particle horizon continues to expand because light from farther distances keeps arriving. But the event horizon, defining which events happening today we will someday observe, is shrinking in practical terms. Accelerated expansion is cutting communication lines. Imagine galaxies as islands in an ocean that is creating more water between them every second. The islands are drifting apart so quickly that if someone lights a bonfire on a neighboring island today, the light from that fire will never reach our shore. The space between us will expand faster than the light can travel. This mechanism produces progressive isolation. The classical observable universe, the 46 billion light-year radius, measures where things are today based on the light they emitted long ago. But if we consider the interactive or reachable universe, it is dramatically smaller. The new calculations emphasize this functionality. They show that Earth's sphere of updated information, the volume over which we could theoretically exchange present-day signals, is only a modest fraction of the total vastness. Many of the galaxies captured in deep-field images from Hubble or James Webb are already, at this very moment, beyond the event horizon. They remain visible, but they are disconnected. They are frozen images from a film that has already ended. The geometry of space itself also plays a fundamental role. If the universe is perfectly flat, as most evidence indicates, parallel lines never meet. But if there were even a subtle curvature, an intrinsic finitude in cosmic shape, distances traveled by light would shift. Recent data have eliminated many uncertainties regarding curvature, confirming a model in which dark energy overwhelmingly dominates. And it is this dominance that dictates the rules. Dark energy does not merely push galaxies apart, it dilutes information. It causes light to lose energy as it travels, a phenomenon known as redshift. The farther light travels through expanding space, the more its waves stretch. A beam that left a primordial star as energetic ultraviolet arrives as faint, cold radio waves. This stretching is not metaphorical, it is physical. There comes a point when light is so elongated that it becomes undetectable, merging into background noise. This imposes a practical limit on the observable universe beyond the theoretical one. Even if light technically arrives, it may be so diluted by accelerated expansion that it no longer carries a coherent image. The universe does not go dark because light stopped, but because light has become a whisper too faint to hear. Behind this discovery lie supercomputers running simulations of billions of years of cosmic evolution. They model the dark matter web connecting galaxies and apply general relativity to see how that web stretches. When these simulations are compared to the most recent observational data, they reveal that the box we inhabit has moving walls. Paradoxically, while the physical universe grows larger, our window onto it becomes relatively more restricted. The fraction of the total universe we can observe is shrinking over time. Understanding these mechanisms brings calm because it replaces inexplicable magic with elegant order. This is not random chaos. It is law. Gravity, light, and dark energy working in silent balance. The observable universe is smaller because nature has a speed limit and a growth rate. Accepting this is like accepting that we cannot see beyond the ocean horizon, not due to a flaw in our eyes, but because of Earth's curvature. The curvature of time and space does the same to us. It places us in a specific location, with a specific view, and wraps the rest of the cosmos in absolute secrecy. This mechanical complexity, far from being cold, gives texture to reality. Knowing that the light we see struggled against expansion, that it was stretched and filtered, that it traveled billions of years just to deliver an image, makes every photon a miracle of physics. The observable universe is a rare gift. It is the outcome of equations that allowed, amid overwhelming expansion, a small bubble of clarity and connection to remain intact around our galaxy. It is inside this bubble, governed by strict and beautiful laws, that our minds can rest, knowing the boundaries are guarded by the most faithful sentinels of nature, the speed of light and the geometry of space-time. We now step into territory where science touches the edge of imagination, where numbers reveal secrets the quiet night sky seems to conceal. Knowing that the observable universe is smaller than we once believed opens the door to profound mysteries, paradoxes that challenge our intuition and discoveries that transform darkness into a veil filled with hidden meaning. We are not merely on a smaller island, we are on an island surrounded by invisible currents and echoes of lands we will never visit. One of the most intriguing phenomena illuminated by this perspective is what has been called the dark flow. Imagine you are in a boat on a calm ocean. There is no visible wind, no waves, and yet you notice that your boat, along with many others, is drifting steadily in a single direction, as though a vast waterfall or colossal magnet lies hidden beyond the horizon. Astronomers have observed something similar happening with entire clusters of galaxies. They appear to be moving at unexpected velocities toward a specific region of the sky, roughly in the direction of the constellations Centaurus and Hydra. The mystery arises because there is not enough visible mass within our observable universe to account for such motion. The unsettling and wondrous implication is that the structure exerting this pull may lie beyond our cosmic bubble, beyond the very boundary that recent calculations have drawn closer. It is like feeling the gravity of a mountain you cannot see because it stands behind an impenetrable wall. The dark flow whispers that the total universe may extend far beyond our accessible portion. Even though our visual walls have narrowed, the influence of what lies outside might still reach across the abyss. To sense this pull is to feel the invisible hand of a larger reality touching the edges of our domain. Another deep mystery emerges when we consider the fate of orphaned light. There are photons emitted billions of years ago by distant galaxies, traveling tirelessly through space in our direction. Yet, because accelerated expansion has shortened our effective reach, some of that light will never arrive. It is condemned to journey forever through a space that stretches faster than it can traverse. It is a letter written that will never be read. The corridor between us and its source lengthens without end. Knowing the cosmos is filled with such lost messages lends it a quiet melancholy. The sky is not only what we see, it is also the archive of all that we will never see, the silent testimony of stories erased by expansion. Within this more restricted cosmic landscape, we also encounter what might be called cosmic ghosts. Many of the galaxies we observe today, especially the most distant ones, no longer exist where and how we see them. Because light takes time to travel, we see their past. With the revised understanding of expansion and event horizons, we now recognize that many of these galaxies have already crossed beyond the point of no return. If we could instantaneously travel to where they appear to be, we would find emptiness. They have been carried beyond our stage. What we see in the sky is often a temporal mirage, a photograph of companions who have already moved to an unreachable address. The observable universe becomes an album of images from friends who have relocated beyond the reach of mail. There are also vast regions of near-nothingness within our own bubble, immense cosmic voids. The Bode's void, for example, stretches across hundreds of millions of light-years with remarkably few galaxies inside it. In a universe now understood to be more tightly bounded in its observability, These empty regions become even more striking. They are deserts within our island. Imagine traveling for 300 million light-years and encountering almost nothing, only darkness and cold. These voids suggest that matter prefers to gather in filaments and clusters, leaving behind enormous expanses of solitude. In a smaller, observable universe, the fact that we reside in a comparatively rich and structured region becomes even more extraordinary. It is like discovering that in a modest house, there are vast unused rooms, making the room where you sit by the fire feel even more intimate. Closer to home lies another gravitational mystery, the Great Attractor. Our own galaxy, along with thousands of others, is drifting toward a region of space that exerts a powerful pull. For a long time, this mass concentration remained hidden behind the dense dust of the Milky Way in what astronomers call the zone of avoidance. Only with advanced X-ray and infrared observations did we begin to perceive the vast structure drawing us inward. We are part of a supercluster known as Laniakea, flowing together toward this gravitational focal point. In a universe where observable limits are more constrained, such local structures gain enormous significance. We are not stationary. We are participants in a cosmic current, moving gently through intergalactic space toward a destination that expansion itself may prevent us from ever fully reaching. Another layer of meaning appears when we realize that we are living in what could be called a golden age of cosmology. Because the horizon of future visibility is effectively shrinking, fewer galaxies will remain observable as time passes. Trillions of years from now, expansion will have carried all distant galaxies beyond the visible boundary. Future observers within our merged galactic island will see only their own stars surrounded by blackness. The evidence of the Big Bang will have faded beyond detectability. They may conclude the universe consists solely of their own galaxy. The knowledge we possess of a once vast and interconnected cosmos will be inaccessible to them. The fact that our observable universe is smaller than once thought reminds us that this window is temporary and precious. We exist at the precise moment when light still bridges the islands. The remarkable uniformity of the cosmic microwave background presents another mystery sharpened by these refinements. No matter where we look, its temperature is nearly identical. How can regions of space that never exchanged light or heat appear so similar? This is known as the horizon problem. Cosmic inflation theory suggests that, in its earliest fraction of a second, the universe expanded exponentially from a tiny, uniform region, smoothing out differences before stretching them apart. Understanding that our current horizon is more constrained helps refine this theory. It suggests that the initial mixing was extraordinarily efficient, creating a cosmos as uniform as a calm lake at dawn. Beyond this lies the provocative idea that our observable universe may be just one bubble among many in a larger multiverse. If our horizon is a hard boundary defined by the speed of light, what prevents other horizons from existing just beyond it? Other bubbles touching ours yet eternally invisible. Perhaps space is vast beyond comprehension but partitioned into isolated neighborhoods. The recalculated size of our observable universe does not diminish reality. It simply clarifies the walls of our garden. Beyond those walls, other stories, other laws of physics may unfold in perpetual silence. Finally, we confront the mystery of vacuum energy itself. Empty space is not truly empty. It seethes with quantum fluctuations, virtual particles appearing and vanishing, and possesses intrinsic energy that drives accelerated expansion. Yet the observed value of this energy is staggeringly smaller than quantum theory predicts. It is one of the greatest mismatches in physics, and yet, it is this gentle vacuum energy that determines the size of our cosmic enclosure. If it were slightly stronger, the universe might tear itself apart. If slightly weaker, it might collapse. The fact that our observable universe has precisely the scale it does, even after being revised downward, suggests a delicate balance that allowed galaxies, stars, and conscious beings to emerge. To navigate these mysteries is to accept that we do not hold every key. The universe conceals its secrets within the fabric of expansion. Realizing our visible world is smaller teaches us that reality is selective. It does not reveal everything. It presents a curated stage where some actors have already exited and others remain hidden in the wings. In that interplay between revealed light and guarded darkness lies the true enchantment of looking upward. It is not only what we know, but what is implied by the silence at the edges. Each visible star is a secret unveiled. Each stretch of dark sky is a secret preserved. gently protecting our rest with the promise that there is always more left to dream. As we understand that the stellar stage upon which our story unfolds is more restricted than earlier imagination assumed, we begin to perceive the invisible threads connecting this cosmic scale to our own biological and cultural existence. The physics of the horizon is not merely an abstract rule governing distant galaxies. It is the architecture that allows life, as we know it, to flourish within a stable environment. There is a profound interdependence between the size of the observable universe and the quiet conditions required for consciousness to awaken. If the walls of reality had been drawn differently, if expansion had not efficiently cooled and isolated regions of space, we might not be here to contemplate the sky at all. This connection begins with something deceptively simple: the darkness of the night. The night sky is dark because the universe is not infinitely old, not static, and not infinitely accessible. If it were eternal and unchanging, every line of sight would eventually end on the surface of a star. The heavens would blaze as brightly as the sun. There would be no gentle contrast between day and night, no darkness to invite rest, no cooling of the planet's surface, no circadian rhythm to guide biology. The darkness that surrounds the stars each evening is a direct consequence of cosmic expansion and of the finite reach of light. The fact that the observable universe is limited, and now understood to be even more restricted, creates the essential contrast that makes sleep possible. The silence of space is the pillow upon which life rests. There is also a thermal balance at play. The universe functions as a vast heat engine. For complex life to exist, energy must flow from a hot source, like the sun, to a cold sink, deep space. Expansion stretches space itself, diluting residual heat from the early universe. It keeps the cosmic background cold enough to absorb excess energy radiated from stars and planets. If expansion were weaker, heat would accumulate. If it were stronger, matter might never have gathered into stars at all. The shrinking of our observable horizon, paradoxically, reflects the same expansion that cools the cosmos. The galaxies disappearing beyond view are the cost of maintaining a cold, stable background against which life can operate. The chill of space is not hostility, it is regulation. This refined understanding also reshapes how we think about life elsewhere. For decades, we looked at the enormous estimated scale of the observable universe and assumed that statistical probability alone guaranteed countless civilizations. Vastness itself felt like assurance. But when we recalibrate our sense of accessible scale, when we recognize that many regions are already causally disconnected, the equation subtly changes. The garden is not infinite, it is bounded. That does not mean we are alone in sadness. It means we are rare in significance. A smaller cosmic arena makes every flame of awareness more precious. Earth becomes less a disposable speck in infinity and more a jewel inside a defined vault. The chemistry of your own body depends on this delicate cosmic tuning. The carbon in your cells was forged in stars that formed because gravity could overcome expansion at just the right rate. If the universe expanded too rapidly in its early stages, matter would never have condensed into stars. If it expanded too slowly, it might have collapsed before complexity could emerge. We inhabit a cosmic Goldilocks balance, not too fast, not too slow. The observable universe, in its revised and slightly more intimate size, reflects that balance. Every breath you take is evidence that expansion unfolded with exquisite precision. There is also a cultural dimension. Human civilization developed under a sky that appeared stable and dependable. The stars did not visibly flee from us on human timescales. Their patterns were consistent enough to guide navigation, agriculture, and calendars. If expansion's effects were dramatically visible within a lifetime, the sky would appear chaotic, unreliable. Instead, its slow, imperceptible evolution allowed us to build myths, mathematics, and meaning. The illusion of permanence, sustained by the immense timescales involved, was a gift. Now that we know the horizon is finite and even slightly closer than once thought, we gain not fear, but gratitude. The sky held still long enough for us to learn to read it. This revised horizon also influences how we think about responsibility. If our observable universe is limited, then everything we can affect, and everything that can affect us, lies within a defined sphere. There is no endless frontier to absorb consequences. We are participants in a closed cosmic ecosystem. The gravitational dance of galaxies, the stability of planetary orbits, the gentle pull of the moon shaping our tides, all occur within this shared enclosure. The boundary of observability becomes a boundary of stewardship. There is a psychological resonance as well. The human mind has always struggled with infinity. The infinite both fascinates and overwhelms. It is too abstract to grasp, too boundless to feel intimate. When science gently draws the edges closer, the cosmos becomes less an abstraction and more a place. A place has boundaries. A place can be inhabited. The observable universe becomes not an endless desert, but a vast, enclosed sanctuary. And sanctuaries invite reverence, not despair. Even the way we pursue knowledge is shaped by this limitation. Knowing that there is a boundary encourages creativity. We cannot physically cross the horizon, so we invent instruments to interpret faint signals, gravitational waves, neutrinos, infrared light. Constraint fuels ingenuity. A fixed frame does not suffocate art, it focuses it. The horizon of the universe is like the edge of a canvas. Within it, infinite patterns can still be painted. Ultimately, the size of the observable universe is a measure of time itself. To look far is to look back. To say the universe is smaller than once estimated is to say that the contour of our accessible past is more defined. We cannot see before a certain moment. We cannot reach beyond a certain boundary. This physical truth mirrors a personal one. There are limits to memory and limits to foresight. Life unfolds in the present. The observable universe is the cosmic version of now, the portion of reality currently connected to us. And perhaps that is the deepest connection of all. The horizon is not a prison. It is a definition of belonging. It tells us where we are, and by extension, who we are. We are beings shaped by light that managed to arrive before the boundary closed. We are thoughts emerging inside a bubble of causality. The universe did not need to be infinite for meaning to exist. It only needed to be coherent, structured, and gently bounded. Inside this recalculated sphere, consciousness arose. Inside it, cultures formed. Inside it, you are breathing at this moment. The vast unknown beyond remains silent, not threatening, not urgent, simply inaccessible. And within what remains visible and connected, there is more than enough complexity, beauty, and mystery to fill a lifetime of quiet wonder. Since the first human being lifted their eyes from the dusty ground and gazed into the star-filled abyss, a silent and profound relationship has existed between our consciousness and the vastness above. The sky has never been a passive backdrop. It has always been a mirror onto which humanity projected its fears, its gods, and its hopes. The discovery that our observable universe is smaller than earlier theoretical estimates suggested is not merely a cold astrophysical adjustment. It reverberates quietly through our cultural and philosophical foundations, subtly reshaping how we position ourselves within creation. For millennia, most ancient civilizations imagined the cosmos as finite and enclosed. The Egyptians saw the sky as the body of the goddess Nut arched over the earth. The Greeks envisioned crystalline celestial spheres. The Hebrews described a firmament separating waters above from waters below. There was psychological comfort in these visions. The world was large, yes, but it had walls and a roof. It was a home. Modern science gradually dismantled that roof. Through Galileo's telescope, Newton's mechanics, and Hubble's discovery of expansion, the ceiling seemed to explode outward into boundless, indifferent infinity. Philosophers spoke of the unsettling silence of infinite spaces. Humanity felt small, not sheltered within a house, but suspended in a limitless void. And yet, in a subtle and refined way, contemporary cosmology returns us to a modern form of enclosure. The observable universe, finite and now recalculated as slightly more restricted than once believed, functions as a new kind of firmament. Not a barrier of crystal, but a barrier of causality. There is a real limit to what we can see, influence, or ever reach. The existence of this boundary reconnects our modern mind with an ancient intuition that we live within a contained domain. This does not diminish us, it grounds us. The infinite, as a mathematical abstraction, is difficult to love. It overwhelms the imagination. But a finite cosmos, even one unimaginably vast, can be inhabited emotionally. A place with a horizon is a place that can be related to. When science draws the edges of our cosmic map slightly closer, it transforms the universe from a concept into a dwelling. This realization influences art and storytelling. For generations, science fiction often imagined humanity spreading endlessly from star to star, conquering the galaxy without limit. Infinity invited expansion without restraint, but a more bounded observable universe shifts the narrative. It introduces a poetics of preservation rather than conquest. If the stage is limited and parts of it are already drifting beyond reach, then what remains becomes precious. The drama intensifies. The fact that the play has a defined stage and a defined duration gives it meaning. An infinite, endless performance would dissolve into noise. The paradox of Fermi also changes tone under this light. If the cosmos were infinitely accessible, the question, "Where is everyone?" carried an implicit assumption of inevitable contact. But in a universe with shrinking causal boundaries, isolation is not necessarily evidence of absence. It may be evidence of separation. Civilizations, if they exist, could be forever beyond our event horizon, visible only as faint ancestral light. This shifts humanity from waiting for cosmic rescue toward embracing cosmic responsibility. We are not abandoned children in an endless desert. We are stewards of our own illuminated island. There is a philosophical resonance with mortality as well. Just as our lives are finite, so too is our access to the cosmos. There is symmetry between the brevity of human existence and the bounded reach of cosmic observation. Accepting that there are limits to what we can see and know cultivates humility. It tempers arrogance. The universe seems to say, "You are capable of understanding the laws of nature, but not of erasing them." A society that refuses limits becomes restless and insatiable. A civilization that accepts boundaries can cultivate contentment. The cosmic horizon teaches restraint, patience, and gratitude. It suggests that not everything is meant to be accessed, and that what is accessible is sufficient. Even our attempts to leave a legacy are reframed. We send spacecraft like the Voyagers carrying messages into the dark. We transmit radio waves containing music and mathematics. We once imagined these signals traveling endlessly, touching the farthest reaches of existence. But a shrinking event horizon reminds us that our sphere of influence is finite. Eventually, those signals will stretch, weaken, and fade into silence. This does not make the gesture meaningless. It makes it poignant. We speak not because we expect eternal echo, but because expression itself is part of being human. Spiritual traditions often describe sacred spaces, sanctuaries set apart from the ordinary world. The observable universe functions in a similar way. It is separated from the unknowable beyond by the speed of light and the expansion of space. Within its boundaries, physical constants are finely tuned for complexity. Beyond them, we do not know. The observable universe becomes a cosmic sanctuary, an oasis of order within potential chaos. To exist within it is to inhabit a rare clearing. There is also a memory dimension. When we observe distant galaxies, we are reading the past written in light. The observable universe is a vast archive. Knowing that this archive has a limit, that we cannot look infinitely backward or outward, deepens our role as conscious witnesses. We are librarians of cosmic memory during a brief window, when the shelves are still illuminated. This perspective even shapes how we answer a child who asks, "Where does the universe end?" Instead of invoking fear or vagueness, we can say gently, "The part we can see ends at a wall of very ancient light, and we are safe inside it." That answer provides orientation. We are not adrift without address. We live at a specific cosmic location: Earth, solar system, Orion Arm, Milky Way, local group, observable universe. A complete and meaningful address. The darkness of the sky takes on new significance. It is not emptiness. It is the presence of a boundary. Learning to see darkness not as absence but as structure is an emotional evolution. Without darkness, there would be no stars visible at all. Without limits, there would be no focus. The boundary frames the beauty. Astronauts speak of the overview effect, a profound cognitive shift when seeing Earth from space as a fragile, borderless sphere. Understanding the observable universe offers a deeper version of that effect. Imagine seeing not only Earth but our entire cosmic bubble as a single fragile enclosure suspended in an unobservable beyond. We are all inhabitants of the same luminous sphere, composed of the same ancient elements, bound by the same expansion. This awareness fosters unity. There is no external rescue, no infinite fallback. There is only this shared domain. The recalculated boundary does not shrink meaning. It concentrates it. We are the conscious layer of this bubble of light. We are the universe looking at itself within the limits allowed by physics. And those limits, once perceived as constraints, become guardians. They give form to our existence, definition to our story, and a quiet roof beneath which we may rest. When we project our awareness forward along the vast timeline stretching into the distant future, the realization that our observable universe is more restricted than once imagined reveals a destiny of profound quiet and increasing isolation. The physics that today draws the boundaries of our luminous bubble will continue to operate, patient, implacable, precise, shaping a reality that future generations may barely recognize. What now appears as a gentle recalibration of cosmic maps is, in truth, the opening act of a long and graceful withdrawal of the visible cosmos. The central figure in this unfolding future is accelerated expansion. Dark energy, the subtle force pushing the fabric of space outward, shows no sign of weakening. It dictates the rhythm of a gradual farewell. The universe we see tonight, filled with billions of galaxies suspended in delicate structure, is a temporary arrangement. As ages pass, the horizon of future visibility will draw inward in practical terms. Not because space will shrink, it will continue to grow, but because fewer and fewer objects will remain causally connected to us. We are living at the beginning of a vast galactic separation. Imagine the Milky Way and its neighboring galaxies as a family gathered inside a warmly lit room. Through the windows, you can still see other houses glowing in the distance. Over unimaginable spans of time, the expansion of space will cause those distant lights to fade. One by one, the neighboring galaxies will cross beyond the event horizon. Their light will stretch into longer wavelengths, dim beyond detection, and eventually vanish entirely from view. The windows will grow dark. In that far future, the observable universe will effectively consist only of our local group, which itself will have merged into a single immense elliptical galaxy formed from the collision of the Milky Way and Andromeda. Astronomers sometimes call this future structure Milkomeda. It will be a colossal island of stars adrift in an ocean of blackness. If intelligent beings exist in that distant era, they will look into the sky and see only their own galactic home. The cosmic microwave background, the faint afterglow of the Big Bang that today provides critical evidence of cosmic origin, will have been stretched to wavelengths larger than the observable region itself. It will be undetectable. The expansion that once revealed the universe's beginning will conceal it. Future astronomers may conclude that their galaxy is the entirety of existence. The grand narrative of cosmic expansion will be erased from observational evidence. In this sense, we inhabit a rare window in cosmic history, a brief epoch when the universe is still transparent enough to reveal its structure. The refinement that made our observable universe slightly smaller reminds us that even now, the horizon is dynamic. It is not fixed. The window is open, but not permanently. There is a quiet serenity in this trajectory. The future is not one of violent collapse, but of gradual dimming. The most widely supported models suggest not a catastrophic tearing apart of matter, but a slow drift toward thermal equilibrium, the so-called heat death or big freeze. Stars will exhaust their nuclear fuel. Bright blue giants will disappear first, leaving behind smaller, longer-lived red dwarfs. For trillions of years, the cosmos will glow softly in deep crimson light. Eventually, even these stars will fade, and stellar remnants, white dwarfs, neutron stars, black holes, will dominate the darkness. In a universe where the observable horizon has contracted to a single galactic island, energy will be precious. Civilizations, if any endure, may harness the rotation of black holes or draw upon residual stellar warmth. The exploration of space will no longer mean venturing into distant galaxies. It will mean navigating within one enclosed cosmic home. Expansion will have placed a permanent boundary around their reach. And yet, there is comfort in this containment. Isolation on cosmic scales does not imply danger. It implies stability. The vast structures beyond will not collapse inward. They will not invade. They will simply recede beyond contact. The universe will become quieter, more introspective. Even time itself will feel different. Without external galaxies as reference points, the passage of cosmic epochs will be marked by rare and subtle events. The slow evaporation of black holes through Hawking radiation, the occasional merger of stellar remnants. Time will stretch into almost inconceivable patience. The frenetic early eras of galaxy formation and collision will be long past. What remains will be a deep, enduring calm. Understanding this distant destiny reframes our present moment. The shrinking effective horizon means that the universe is gradually forgetting its own history. Ancient light is slipping beyond the boundary. What we see tonight will not be visible forever. In that sense, we are archivists of a fleeting cosmic memory. We are recording and interpreting a sky that future ages will never witness. This awareness does not call for urgency and fear. It calls for quiet appreciation. The sky above us is not permanent in its current form. The galaxies we observe are present because we exist at a precise intersection of cosmic timing. Too early, and the universe would have been too hot and chaotic for structure. Too late, and the evidence of its vastness would have faded into darkness. The observable universe, even in its recalculated and slightly more intimate dimensions, is a temporary configuration. It is like a tide that has reached its fullest extent before slowly receding. We are standing at that shoreline. There is a profound stillness in recognizing that the future of the cosmos is one of increasing silence. No encroaching catastrophe, no sudden collapse, just a gradual closing of curtains. The expansion that once fueled blazing creation now orchestrates gentle retreat. And as those distant lights one day slip away, what remains will be enough. The stars that matter, the ones gravitationally bound within our island, will continue their slow dance. Matter will reorganize. Perhaps life, adapted to new conditions, will persist in forms we cannot imagine. For now, we rest within a universe that is still luminous, still expansive, still generous in its revelations. The boundaries are there, yes, slightly closer than once believed, but they are patient boundaries. They do not rush. They move with the tempo of eternity. Knowing this allows us to soften our worries. The cosmos is not spiraling toward chaos. It is gliding toward quiet. The horizon is not advancing to imprison us. It is settling gently into place. And tonight, beneath this temporary canopy of galaxies, we remain sheltered inside our bubble of light, aware, breathing, held within limits that give shape to our story. As we gently fold the map of tonight's reflection and prepare to rest, the image we carry with us is no longer that of an endless abyss stretching without care or boundary. Instead, it is the image of a refuge, a cosmos drawn with precision, its horizons measured not to confine us, but to shelter us. We began by discovering that the observable universe is smaller than earlier generations of cosmologists believed, a subtle recalculation, a refinement of numbers. And yet, what appears mathematically modest becomes philosophically immense. The frontier moved closer. The sphere tightened. The horizon approached. But nothing was taken from us that we ever truly possessed. The galaxies beyond that refined boundary were never places we could reach. They were never destinations for ships or homes for travelers. They were distant embers whose light happened for a time to cross the expanding sea of space. If some of them now lie beyond permanent contact, it does not impoverish our reality. It clarifies it. We do not inhabit an infinite desert. We inhabit a defined sanctuary. Within this recalculated sphere lies everything that can ever influence us. Every star whose gravity can subtly tug on ours. Every photon that can warm our eyes. Every galaxy whose ancient light can tell its story. Outside that sphere, expansion weaves silence. Not hostility, not threat, just distance. There is something deeply calming in that thought. The universe in its vastness has given us a domain, not limitless but sufficient. Sufficient for stars to form, sufficient for carbon to ignite in stellar cores, sufficient for planets to cool, sufficient for oceans to gather, sufficient for life to awaken, sufficient for consciousness to ask questions. And perhaps sufficiency is more beautiful than infinity. Infinity overwhelms. It dissolves focus. It erases scale. But a finite horizon, even one measured in billions of light years, gives contour. It allows meaning to take shape. It frames existence the way a shoreline frames the sea. Each star you might glimpse tonight belongs to this shared enclosure. Each photon that arrives has outrun expansion long enough to reach you. Each visible galaxy is part of a rare and temporary configuration in cosmic history. A moment when the universe is transparent enough to reveal its structure, yet calm enough to sustain observers. We are living inside that moment. The shrinking effective horizon does not signal loss. It signals intimacy. The cosmos is not pulling away in rejection. It is settling into stillness. The boundaries are not bars. They are walls of a cathedral, holding the air, shaping the acoustics, giving resonance to every whisper. Inside this bubble of light, gravity binds galaxies into filaments, stars into systems, planets into orbits. Inside it, your heartbeat aligns with the same physical laws that guide nebulae and quasars. Inside it, the constants of nature balance with such precision that atoms can assemble into thought. And beyond it, there is quiet. Not emptiness in the emotional sense, but unreachability in the physical sense. A gentle curtain drawn by the speed of light and the expansion of space-time. A boundary that protects coherence. A cosmic shoreline. Tonight, as you rest, remember that you are not suspended in a formless infinity. You are centered within your own observable sphere, a region of causality that surrounds you in every direction. Wherever you are at its center. So is every other conscious being. Each of us inhabits a personal midpoint within the same shared bubble. The universe did not need to be infinite for your existence to matter. It only needed to be ordered, bounded, and patient. The recalculation of cosmic distance, this subtle tightening of the map, reveals that we are held within something shaped, something measurable, something finite yet vast, beyond daily comprehension. And within that finitude lies extraordinary grace. The stars beyond the horizon will never trouble us. The galaxies already drifting beyond contact will not collapse inward. The future, though quiet, is not violent. It is calm. The expansion that carries distant light away also ensures that our local island remains undisturbed. We are cradled by physics, so let the horizon rest where it is. Let the unreachable remain unreachable. Let the ancient light that has already arrived be enough. You are inside a sphere of stories told by photons. Inside a cathedral whose ceiling is the particle horizon. Inside a cosmic garden whose walls are drawn by relativity itself. And that is enough. If this reflection brought you a sense of calm perspective, consider continuing these journeys with Cosmos for rest. Quiet science has a way of placing us gently within reality, not at its edge, but at its center. There are many more nights ahead, and many more frontiers to explore together, slowly, thoughtfully, and without hurry. Now, breathe softly. The universe has its limits, and within them, you are safe.